Sometimes students get a little bit confused about the distribution property. They see something like this, x times yz, and they say, oh, I need to multiply everybody by x. They make it look something like this, x times y, x times z. Is that true? Well, to give you a sense of whether it's true or not, let me take a look at a numerical example. Is 3 times 4 times 5 equal to 3 times 4 times 3 times 5? Well, let's see. 4 times 5 is just 20. 3 times 3 is 9. 4 times 5 is 20. And we see that they're not true. This is 60. This is 180. So what you really wanted to do here was just, oh, well, actually, let's back up here a second. The problem is you have an extra 3 in there. You add in an extra factor of 3. So what you really wanted here was just x, y, z. Now with that said, when is this sort of thing true? Well, it's true when we're talking about the distributive property. So in other words, if I have 3 times 4 plus 5, so now I'm adding, that is true. In other words, the 3 is going to apply to both of those guys. Seen with letters, that's the same thing as saying that x times y plus z is x times y plus x times z. To show you why this is true, I'm going to draw a diagram, draw a box, and we'll see what's going on. So let's see. Let me draw a box, and I'm going to divide it so that it has length of 3, or width of 3, and length of 4 plus 5. The left-hand side is then the area of this box, 3 times 4 plus 5. But isn't that the same area as 3 times 4, in other words, the first box, plus 3 times 5, the second box? So that's why this sort of statement is true. So in summary, when we're multiplying, we're just multiplying through once. Or you have this sort of problem. If you've got this combination of multiplying and adding, then you need to distribute it through to both pieces.